Welcome back, everyone. This is October, or Cybersecurity Awareness Month for 2021, and I wanted to create a project that would explain a little bit more about some password security and some best practices that you should follow so that you can have a safe experience with your accounts, or as safe as possible. I've added some more information here. By no means is this an exhaustive list. And again, do not enter a password that you are currently using or will use in the future. Only use either old passwords or something that you're just never ever going to use. Not that I'm saving anything in here. I want to make that very clear that there's nothing being saved on any database, any server, anything. Anything you input will only be on your computer. But just as a good habit, do not add anything to here that you're going to be using or you are currently using. So kind of my tips for the best practices. One, change your passwords often. I change mine at roughly every 90 days. So something like that. Maybe not every day. That seems a bit much, but you want to change them periodically so that if someone has hacked it and gotten into, has that saved, that they're going to have to redo all of that in order to get back to that status. Make your passwords long so that it is much harder for them to crack it if they ever do. And include letters, numbers, and special characters. And we're going to show you down here why that's so important. So if we add, let's say OneFinDog as our password, it's going to go in as straight text, and they're going to hash that value. And this is what the hash will come out as. So it's a whole bunch of letters and numbers. And there's no salt here, so that is going to be the same with the salt. What a salt does is it adds to the password. Now, the user's never going to be aware if this is happening or not, or even what that value would be. So for instance, if I had one, and I had a application that took in people's usernames and passwords, when they went to create their account on the back end, I would add with their password a salt. And you can see here how they're concatenated together or added together. Then I would hash that and I would save the username, the salt for that user, which it may vary for different users. Usually it should. They're also usually much longer than this. I was reading that they're roughly about 32. They kind of start out at about 32 characters long. So clearly this is much shorter than that. So they'll save the username, the salt for that user, and they'll save the hash. So the plain text is never saved. What then happens is when you log back in, you type in your username, you type in your password, it's going to go find what the username was, what the salt was. It's going to add it to the username or to the password you just entered, hash it, and it should match. The password it just hashed with the salt should match what's already in the database. If it does, you're logged in. If not, it says that you entered something in wrong. So that's how that part works. I then wanted to give a little bit of stats on why complexity is so important. And what I mean by complexity, again, is using numbers and letters and special characters. So if we use numbers only, then this is how many permutations someone's going to have to brute force do just to crack the password alone. If it's with the salt, then it's up to this amount. And again, that means that it's only cycling through each of the spaces, each of the spaces, 0 to 9, which clearly I only used one number in there. So it's going to be more than that for me. One case, meaning someone only used the alphabet and they only used it in either uppercase or lowercase, then this is how many permutations there would be for just the password. And then this is how many there would be for the password plus the salt. And if they have uppercase and lowercase, which I do, but it still doesn't quite count because I also have a number in there, then this is what you're looking at. If you have letters and numbers, which is what I have, now we're talking this many permutations just for the password alone, and then this with the salt. So we're talking quite a bit large number. Then had I added a special character, then we jump even further. So if it was just this without the salt, roughly using letters, numbers, and special characters, it's going to take 10.09 millennium to brute force it. And that's to get through everything all the way to the end. So obviously it'd be less than that here, but to do everything, this is the maximum amount of time it would take. Once I've added that salt, it greatly increases that. I mean, it just exponentially grew from 10 millennium to many, 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 many more millennium than that. This is why it's so important to have a long password. And then it's good for an application to add a salt to it so that it automatically increases the length. And if they were to look over your shoulder, or if they're able to attack the database, then it's going to be even harder for them to have what's called like a rainbow file where they've already pre-hashed a lot of values, because there's this extraneous salt added here. Now for the code. CSS, pretty simple. We've got 2 tables in there, and I have just made them 100%, and I've centered them. I have a hash text, and I just wanted to decrease the size, so that shows in that second table the password, the hash, the salt with the password, and then the hash with the salt. I wanted to make that so it all fit. And then I have this password wrapper, which is up top where you have the password and the salt, and I just wanted to center both of those. For the HTML, pretty basic as before. If you've looked at my other projects, have my introduction here. Just bolded a few things. This is the card that has the password wrapper in it. So we have the password with its input. When it changes, it updates the password. With salt, same thing. It has a different ID. And when it updates, or when it changes, it doesn't update password as well. We then have the search stats table, and that just gives all that data on how long it takes to brute force attack it. And again, that's with JavaScript, which is not ideally what you would use to brute force attack it, but that is what that is. And we'll talk about that when we get to the JS. And then we have the permutations table, and that just is the password, the hash, the salt with the password, and then the hash with the salt. We did use the SHA-256, and SHA is Secure Hashing Algorithm 256. And I use this in another project as well, but I use that from this person's code, and so I just wanted to give them credit and a link so you can go directly to their page and look at what they've done. And then I have a link to my JS so that we can, so it'll load it in our footer. Now to the meat and potatoes. Again, I have that link again for the SHA-256 so that anyone can go and look at that. So we automatically set the password and the salt to be empty strings. We have the column headers for the stats table. The first one's empty because that's where I want to have the row headers, which we'll see here as password and with salt. And then I have just the numbers only, one case, and so forth. And I initially set everything to 0, and then 1,000 is 0. What this means is how long does it take for 1,000 iterations to go through in a for loop. It's not the best way to calculate this, but this is how I'm able to figure out what the person who started this application up and see how fast their computer is, to give them an idea of how long it would take to brute force it with their computer in JS. So we'll just jump down to the bottom real quick. So on load, I call this password security load, which is right here. We print the stats table, so it'll just print everything, those headers and the rows empty, or zeros. Set the password table headers, and so that is the second table. I'm just printing them to have the different headers. So again, it's that password, hash with salt, and hash with salt. Then I have the start. So I'm going to get a date, which really I'm trying to get the time out of that. I put that in the start. I call this get time to search. And then when that's done, I get the date again. I subtract it and get the days out of it. And so I figure out how many days will it take to iterate through 1,000. So if we go up here, get time to search, it's an async function. I want to await this function to get done, and I want it to be 1,000 iterations. And search is here, send in 1,000, it's going to loop through 1,000 times. It's just doing a quick SHA-256 of I, and just checking to see if it's equal to an empty string, which obviously it's not, but I wanted it to do something in there to give it a little bit of time. And then I save all of that. I save that here. So it may take 0.0003 days to do that. Then I'll use that a little bit down there, and I'll show that in a second. So when we call update password, which is really where everything is triggered, password gets updated to the password input, salt gets updated from the salt input, get total number of permutations. So if there's only 10 numbers, so there's 10 for numbers only, so that's 0 through 9, 26 for the alphabet in one case, so A through Z. For both uppercase and lowercase, obviously that's 52 possible letters, or possible options, 62 if you've got letters and numbers, and then 95 when you include all characters as well. And so I set the column data, which is up here, for each one of those. So it's going to be the power of how many options there are to the length of the password. And then we have this get brute force time. And so that's where I calculate here. I give it the days, which again is going to be the previous column. So I'm only using the max amount, dividing it by 1,000, and multiplying it by however many days it takes for 1,000. So again, this isn't the best, most accurate thing, but it gives a good idea of how long it's going to take for the brute force. And then I should make it a little more readable. So if it's less than a day, then I just say it's less than a day. If it's less than a year, then I give it in days. If it's less than 10 years, less than a decade, 10 years, then I give it in years. If it's less than a century, then I give it in decades. If it's less than a millennium, I give it in centuries. And then everything else is just in millennium. So that'll get saved up here. We then do the print stats table. And so this is where I've got my 3 different columns. And it's just going to go through and print. It's going to iterate through the arrays from above. So if it's the first one, then everything's going to be a header because it's that first column. And then everything else is just a header with the 2 rows. And so again, it's going to be just printing out this. So I can add to it, remove from it, and I don't have to update this because it automatically will do it for me. And then I just add them in each of their rows to the search stats table. Then I want to add the password row. And so what that's going to do is on that second table, it's going to actually add the row. And so it just goes in here and it adds the password, the SHA-256, so the hash of the password. Then it'll be the password, the password with the salt, and I just bold out the salt so that you can see it. And then I also hash this password with the salt, and then we show all of that in a row, or add it as a row. So I just concatenate it. And then this is the set password table headers. And so this is just, again, showing that hash with salt. Password, hash with salt, and hash with salt. And this is the SHA-256 function that I used from here. So again, I have it linked to where I got that from. So I'm not going to go through that because I didn't code it. And that is how this is all programmed. So stay safe out there, change your passwords often, and have some fun learning how long it's going to take to crack a password of length that you're using. And if you're using it just numbers, just letters, numbers and letters, numbers and symbols, whatever your combination is, you can see how long it's going to take for someone to brute force attack it. Thank you very much, and like and subscribe.